Welcome to a lesson with Dr. Powell. Let's take a look at how we can find the distance from a point to a line in 3 dimensions. So what do we need? Pretty much what we need is we need to know if we were to have something orthogonal here, we need to know what that length is. How can we get it? Why don't we just take any point at all on the line, form like a vector or something, and actually, instead of projecting it this way, let's just project it down. Guess how we find this then? Pythagorean theorem, then we're done. It's one way of doing it. Maybe another way of doing it, perhaps, is if you had the direction right here, the line was going, and you have this vector right here, maybe you could find the angle between the two, and then you could take the sine, then you could take just this distance times the sine. I guess that would also work too. You could do it. You could do it either way, as long as you have this distance from here to here. So there's really multiple ways of doing this. In this particular case, you just have to play with it and be creative. So, well, let's just look at a particular instance and do it at least one way. So let's take a line, and let's say the line is given by a vector equation. Suppose it's something like t plus 1, negative t plus 2, and 3t, just like that. Okay, so that's our vector equation. And let's suppose that our point right here is, make it 2, negative 3, and 5. Okay, so which way should we proceed? Well, let's first think about this. What's this direction? Do we know a vector that goes along parallel to this? Actually, from the equation of the line, you should actually see it, kind of how fast this is growing with respect to t in each direction. Actually gives us something along this. In other words, look at the coefficients of t in each component. We get 1, negative 1, and 3. This is a vector that's parallel. It goes in line with the line. All right. Next, why don't we do this? Why don't we do this sine kind of technique here, if we can get this angle? All right. So let's take a look at that. So in order to do that, or maybe we just use the cosine. I don't know. We'll just see what we do. Let's kind of see. Whatever we do, we need a vector that goes from here to here, don't we? So let's see. We just need a point on the line. So let's figure out a point on the line. To get a point on the line, you can just plug in a t value, any t value, just a simple one. Why don't we just plug in 0? If you plug in 0, you're going to get 1, 2, 0. Okay, so let's just take that one. 1, 2, 0. That's a point on the line. At this point, the vector between them is simply going to be this guy minus that guy. So 2 minus 1, give you a 1. Negative 3 minus 2, give you a negative 5. 5 minus 0, that would just be 5. Okay, so we have this vector that goes from here to here. All right. So, great. Maybe we just do projection. Just do projection. Because honestly, if we're finding the angle, we're doing a projection anyway. We may as well just do this. Let's just find this projected length right here. So to do that, let's just take this dotted with this, which is in line right here. But the trade-off is whatever you project onto, it has to be a unit vector in order for it to be projection if we do dot product. So we need to make this a unit vector when we do a dot product. Let's line this up. We have 1, negative 5, 5. We're projecting it onto 1, negative 1, 3. But wherever we're projecting onto, need to make it a unit vector. So we have 1 plus 1 plus 3 squared, 1 squared plus 1 squared plus 3 squared, finding the length of this. So that would be square root of 11. Okay, so 1 over the length multiplied makes us a unit vector. Now we can take a dot product. So we have 1 plus 5 plus 15. There's 1 over square root of 11. And that becomes 21 over square root of 11. Okay, so that's the projected length right down here. So 21 over square root of 11. Now, how long is this from here to here? Well, this is the vector right here that describes it, that we got from this minus that. So we just need to find the length of that. Okay, so we know this length, but to find that length, so maybe I'll draw a triangle down here, what I'm looking at. So looking at a triangle here, I know this is 21 over root 11. This length is going to be, let's take 1 squared plus 5 squared plus 5 squared. So we're looking at what, square root of 51. Okay, and then we just need to know that, and that'll be the distance. But we can, let's just do that using the Pythagorean theorem. It's not too bad. So pretty much what it is, the square root of this squared minus that squared. So which is, we get 51 minus 21 squared, which happens to be 441, I believe. 441 over 11. Okay, and let me just double check that here. 1 and, oh yeah, it's just that. Okay, so it's 1 and 4 and 2, yeah, so 441. Okay, over 11, and then we have, right, so then making that to one fraction, we have what, 561, because you multiply that by 11, minus 441 all over 11. So it looks like what, 120 over 11 is what we're getting, 120 over 11. And then we need to take a square root of that. So that the square root of 120 over 11 looks like, so I'm just using the Pythagorean theorem, and I get that length right there as square root of quantity 120 over 11. Well, what I did is I squared this guy, squared that guy, and then I subtracted the two, and then I took a square root of that result. And I end up, and that's the distance from the point to the line. Thanks for watching.